Hello, good evening, and welcome everyone to this session. I think all of you who are logged in on WebEx, you also need to go to joinpd.com and enter this code WPGEKJ. And the questions that I ask on the slides, you have to answer on joinpd.com. Okay. Let's wait for a couple of minutes more to let a few more people start with us, and we'll get started. 1 or 2 more minutes. See, I'll wait for about 10 to 15 students to connect on joinpd.com. Usually that's a reasonable indicator of quorum. I see about 3 or 4 more. I see many more on WebEx, so I guess make sure you join on joinpd.com as well, because that's where you'll be answering questions. So this session once again is on week 5 and 6. I was looking at the topics that people found most challenging. I think in week 5, the challenging things were the normal distribution, exponential distribution, and functions of a random variable. So I have problems in those 3 areas. And in week 6, it was multiple continuous random variables, and there were challenges in just joint distribution, marginal, conditional, things like that. And I have a few problems on that as well. But generally, I want to tell you, I think the if you look at data science in general, it's not exactly probability theory in some sense. So a lot of things, if you look at probability textbooks, if you look at continuous random variables, there'll be lots of integration, and the entire thing focus will be on problems in integration. And we are not going to focus on that in this program. So it'll be a little bit simpler, but you have to have the understanding of what how continuous distributions look like, what is the meaning of expectation, a little bit of integration is good to know, and then general behavior of multiple random variables when they're continuous. How does their like a scatter plot from there, what can you say about dependencies and all that. So that kind of notion is important. Okay, so I think there are enough people on Join PD, so let's just get started. So there are quite a few problems. I'll go at a reasonable pace depending on the complexity of the problem, etc. Okay. So the first question, okay, before we start, a quick recap of how to attack problems with normal distribution. There is 2 parameters in the normal distribution, mean mu and variance sigma square. There is this complex looking expression for the PDF, but a lot of people like this bell curve picture better. They would just look at this and know this is how a Gaussian would look. It's a little bit more tricky, I mean, how it falls is exponential, e power minus x minus mu squared, all that is important. But there is this very, very nice relationship, which basically this normal distribution with mean 0 and variance 1, we will denote z as the some random variable which has the distribution. It's called the standard normal. And the CDF of the standard normal, CDF is probability that z is less than or equal to x. I will denote that as fz of x. Okay, so this notation is sort of important because the CDF of the standard normal is enough. For any probability computation with normal distribution, your answer typically will be in terms of the CDF of the standard normal, and any reasonable computer package for probability computations will give you this as one of the functions. So you can evaluate fz. Okay, and as far as our exams are concerned, fz is known. We'll assume fz is known. So you can express answers in terms of fz. Okay, so that's important. Now, what's critical is this very interesting relationship. If you take x to be normal, mean, mu, and variance sigma squared, it turns out x minus mu by sigma is actually standard normal. Okay, so the CDF simply becomes x minus mu by sigma, same FC, but instead of evaluating it at x, you evaluated x minus mu by sigma. It's a small little shift in the way we compute, and then all these relationships become possible, right? So ultimately, we're interested in computing probabilities, right? So this whole PDF, CDF, and everything is a convenient tool to compute probabilities, and probability that your random variable x is less than small x is just this expressed in terms of fc greater than is 1 minus that, we know that's true, and probability that x is between a and b is just this difference. So this is these are identities we'll use again and again and again when you do computations with normal distributions. So I cannot emphasize normal distributions more. They are extremely, extremely important. They show up all the time. Most applications, you will, I mean, generally, if you don't know anything, you just assume it's normal. Okay, so it's very, very, very important. So computations like what I'm going to show you are very, very vital in this area. Okay, so let's get started. I'll ask very simple questions to begin with and slowly maybe complicate things a little bit more. Okay, so let's get started. So here's the first question, and you can go in and put your answer in joinpd.com. I see people are beginning to respond already. So you have a normally distributed random variable x, mean is 10 and variance is 25. Okay. And I've asked here, what is probability that x is less than 5? So what is this event? What's the probability of this event that x is below 5 when the distribution has a mean of 10 and variance of 25? So you will express the answer in terms of fz. That's good enough. Be careful with variance being sigma squared and not sigma. And the CDF formula I showed you for probability involves sigma. It's a common mistake that students make. Okay, so we wait for 3 or 4 responses and then I'll show you the answer. Okay, so I think that's enough time. So let's go in and see the responses. Okay, somebody says fz of 35. Somebody has said -1, -1, -1. There's quite a few minus ones, and then 35. How do you get 35? I see 2 answers here. How did you get 35? The person who got 35, maybe you can write your formula. 35 was uh, okay. I see the mistake you're making. See. X is less than 5 is the question that is asked. So x minus 10 by 5 is less than what? 5 again? How is that possible? It will be 5 minus 10 by 5, right? Think about that, right? So the original event is x is less than 5. So if you say x minus 10 by 5, which is what is the conversion to uh, the standard normal, I agree. But right hand side also you should do the same thing, right? It's less than 5 minus 10 by 5. It's not 5 again. Okay? Is that okay? So pay attention to that. When you're converting from the event that's given in terms of x to the standard normal, you should not just ignore the right hand side, right? Yeah, 5 minus 10 by 5, so you'll get minus 1. Okay, so hopefully that's clear. Okay, be careful about this. When the random variable goes through the transform x minus 10 by 5, the event also transforms. Okay, good. So that's the first one done. Let's move to the next one. It's a very similar type problem, but there is a bit of a twist in the problem. I've asked the same mean, same variance. Now it's probability that x is greater than 15. So a couple of things will change. This is greater. Okay, so you should remember how CDF works with the right hand side, right? X greater. So you should remember what you have to do. Then, of course, convert from x to the standard norm. Okay, people are answering at a fairly fast clip now. So let me just show you what the responses are. 1 minus fz of 1. There is a 1 minus fz of minus 1. Check what you did there. 1 minus fz of 1 is correct. A lot of people have got 1 minus fz of 1. That's good to see. Okay, it's not minus 1. Okay, so there was a minus 1 up here somewhere, and that's not correct. It's 1 minus fz of 1. Okay, good. Good. So this one looks like most people have nailed it down. So let me go ahead and quickly go to the third question. It says the same setting, same distribution. What is the probability that x falls between 8 and 12? Hopefully by now people are used to it. Okay, I think enough people have responded. I see about more than half responding. So let me go through. This is a reasonably easy problem. Okay, there you go. So you see most people have got it right. FC of 2 by 5 minus FC of minus 2 by 5. 0.4 minus 0.4. Look at that simplification. We'll come to that simplification soon enough. I have a problem definitely on that simplification. So most people have got it right. Good, good, good. So the most important topic in continuous random variable, people seem to be comfortable with. Let me say that, repeat that once again for the probably the nth time. The most important distribution of all is the normal distribution, and any probability like this you should be able to very readily compute. Let's see more computations now. We will start using something called the symmetry in normal distribution. You saw the bell curve. Bell curve is symmetric about the midpoint. So about the mean, right? So when x is equal to mu. Okay, sorry. I think I wanted to show you solutions for the first three. Sorry about that. Here are solutions real quick for those who are working it out and maybe didn't get to the correct answer in time. So first thing to identify when a normal distribution is given is what is mu, what's sigma. And then from there, you know x minus mu by sigma is going to be the standard normal. So this is the transformation you have to do. Any event that's given in terms of x, you transform it to x minus 10 by 5. So when you do this less than 5, it's going to go both ways here, and then x minus 10 by 5 is less than 1. So this is x minus 10 by 5 is normal 0, 1, and that is just fz of minus 1. Okay. And greater than 15 also goes through the same thing, except that, this 1 minus would come because this is greater, and you'll have to just look at that and evaluate. And once you do this, the peer deck code is just a little bit above. It's there on the top right. Can somebody put the peer deck code for Aniket's benefit, please? So fc of 2 by 5 minus fc of minus 2 by 5 is the correct answer. Okay, so that's the one. Okay, so now we move on to the next question. It's slightly tricky. I'm not given the variance. So you see x is normally distributed with mean 0. Mean is given. So the line about which it's symmetric is given. Keep that in mind. Then I'm guessing probability that x is less than minus 5 is 0.1. So this sort of indirectly gives you the variance, by the way. So an interesting problem, maybe somebody can answer even now, what is the variance of x? Okay, supposing I tell you probability that x is less than minus 5 is 0.1. What is the variance of x? I mean, you need a numerical package to compute it, by the way. It's a challenge, you don't have to do it. But what is easier to compute once they give you probability that x is less than minus 5 is what is probability that x is greater than 5? Okay, so like I said, there is the symmetry, and probability is area under the curve. So if you use these two, you can quickly answer without any computation. Okay, so let me give a quick minute. Anyway, if somebody is interested in finding the variance of this x, you can try to find it. Don't randomly guess. Think about it. It's a little bit more difficult to rotate. You need a numerical package. It's not, I didn't pick a comfortable number like 1. I just picked probability to be minus point, x less than minus 5 to be 0.1. Okay, so there are enough people who have responded. Let's go take a look. Okay, there you go. People asking how do we find sigma. Okay, Manu says 9. Okay, we'll come back to that. 0.1. I think most people have got 0.1. Very nice. Very, very nice. Good. 0.9. How did you get 0.9? You got misled a little bit by the situation. It's 0.1. Think about that carefully. So it's a symmetric shape, right? So if you're above less than minus 5, above 5, both areas are the same. Okay, there is that 1 minus confusion. So if you start writing out equations, you may go wrong, but think about it carefully. So how do you find sigma? How do you find sigma? Let me see. Who can give a method? There you go. Presta has given a very clear answer. So you need to find the in the z distribution fz, what value of x will give you 0.1. You have to find that. And then what do you equate to that value? How do you solve for sigma? Okay, supposing I find that value. If you want, I can look up and tell you that value in Python. It's pretty quick. Okay. Supposing that value is some minus something, it will be minus something. How will you find sigma from that? Minus 5 by sigma equal to that value. Are you sure it's minus 5 by sigma? Okay, yeah. Okay. Okay, all right. So that's correct. I think Presta's answer is correct. Minus 5 by sigma is equal to that value which you get there. Okay, good. So these kind of things are good to know. So you see that this indirect ways to get to some nice results about Gaussian distribution. So somebody gives you the mean of the Gaussian and one probability, right? Any one probability, which is tail probability on either side, you can actually find the variance. Interesting, isn't it? So it's all similar things. Okay, so now let's push the symmetry a little bit more. What about this guy? Okay, so I've given the same random variable, but now I'm saying x less than -5 is 0.1. What do you do for probability of -5 less than x less than 5? So it's slightly different from the previous case, right? How do you go about it? Okay, yes, I think I see Samit's answer, which is very abstract and very comfortable, but it's nowhere near numerical. So far, let me assure you, nobody has given me a numerical answer. Right? You have to be very proficient in using a package to quickly tell you what is FC inverse of 0.1. Once you find that, you're done. In SciPy stats, it's usually a function called st. I mean, if scipy.stats.norm.ppf of 0.1, it'll give you the answer. Okay, so this one, oh wow, such a fast response. About 19 people have already said yes. 0.8, yeah, there you go. There you go, 0.8. It's sort of trivial in some sense. But this fact is very important. Quite often, oh, 0.9. 0.9 is not quite right. There are two tails, right? So my question is about between -5 and 5. So you have to subtract the 0.1, which is below 0.5, -5, and you also have to subtract a 0.1, which is above 5. Okay, so this probability is 1 minus 0.1 minus 0.1. That's 0.2. Okay, so final question. It's very, very simple again. Just a little twist around the thing. So these kind of probabilities you will meet, maybe you've already met them if you are keeping up to date with the syllabus. When you look at confidence intervals and all that, Gaussian distributions, you will have you'll have to look at the area around the mean, which is 0.95 probability, 0.9 probability, and then how you find that is by looking at one of these tails, and that's I'll quickly tell you where it needs to go. Okay, people have come very, very close. I mean, there's so many people answering 0.025. That's perfect. It's very nice. 0.25. I think you missed a zero. 1 minus 0.95 is 0.05, and you divide by 2, you will get 0.025. Okay, so that's good. That's good. Oh, somebody doesn't want to do that computation, just given the expression. Okay, there you go. Good. So I think symmetry and normal, we seem to understand. Let's now move towards the slightly more tricky thing of this normal inverse inverse CDF. Okay, so I want you to write some answers in terms of the inverse CDF, because like I said, this st.norm.scipystats.norm.ppf, which is the inverse CDF, is very useful in calculations. If you're doing any calculations with data, it's a function that you often call. So it's good to sort of write it out sometimes and then get used to this. So I have a normally distributed a random variable with mean 10 and variance 25. Okay, I want you to find a such that probability of x less than a is 0.05. Okay, now you can express your answer in terms of FC inverse. You don't need to exactly find it. But in the meantime, let me just quickly go and show you the solutions for Q2. I've written up some solutions. If I can go to the next page, yeah, there you go. So this picture is sort of nice to remember. About 0, you have symmetry. So if you have -5 and +5, it should be the same. So you just get 0.1. And once you have the symmetry, and once you know that these three things have to add up to 1, and you know this and that are the same, every other equation just follows from there. Okay, so straightforward enough. So there's a question from Aniket on to having a hard copy of John Rice's book. I like John Rice's book. I think it's one of the best books to learn probability and stats in a slightly more modern way. And I have a hard copy. Okay, I don't know if that answers your question, but I do have a hard copy of John Rice's book. I'm a slightly old style guy with respect to books. I still can't understand if I read from Kindle. Okay, so you can call it whatever. I think it's the old generation. I'm sure there are a few people in this class who are like me. You feel like you understand only when you read from a hard copy of a book. I don't know. It's just age, I think. See, I have one person who's supporting me. Okay, we wait. Oh, no, 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 no. Inverse is FC inverse. Okay, so I think inventors of Kindle should actually invent one of these scent dispersers, so that you get that old book feel when you read from Kindle. Anyway, that's a patentable idea, I think. Anyway, so let's so FC inverse is the function inverse. Okay, inverse CDF. It's not 1 minus FC. So that's different. Okay, that you can maybe say complement or something like that. But this is FC inverse. See, remember every CDF is a monotonic function, no, from 0 to 1. Okay, so if I give you the value of x, you can find fz of x. If I give you the value of fz of x, you can also find x. You can go back and forth. So the inverse is uh, it's the function inverse, right? So if thing that's being asked. Okay, so this kind of computation is important. Okay, so you will face this computation often. And let me see if people have got it right. Okay, so I think enough people have attempted. I can go in and see C inverse of minus 1.99. Okay, F inverse. I think people have struggled to write F inverse. How do you write F inverse? I think something like that you write. You can call F inverse as G if you like. So it's easier for you. Okay. Okay, so I seem to have done something here which I don't like. Just hold on 1 minute. Oh, okay. It's interesting. Right here. Okay. Okay, so I seem to have messed up my solutions a little bit. So I've written up something else. So let me just see if quickly get that out. It's x minus 10 by 5 less than a minus 10 by 5. So fc of a minus 10 by 5 equals 0.5. So fc inverse a should be 5 times Yeah, so an expression like this, I think, is correct. This one is correct, I think, right? If 5 times Fc inverse of 0.05 plus 10. That should be the correct answer. Okay, people have struggled to express this clearly. Yeah, so I think this answer is very cleanly written out. 5 times Fc inverse of 0.05 plus 10. Okay, so what I've done, I seem to have messed up something between my solutions and the question. I apologize for that. So I'll come back and fix that maybe later. But now let's move on to the next question, or maybe I should show you the solution for this one. I think people seem to have struggled a little bit. So let me do one thing. I'll let me move on to, let me see if I can. Okay, so let me just quickly show the solution here. So what I've done, I don't know how this came about. For some reason, I seem to have given a different question in that, and the solution is for a different question. Okay. So let's just go through the version of the solution here. I apologize for this bug, guys. I think I was careful, but something is not gone on properly. Okay. So this question is slightly different. The solution is slightly different. It says find A such that probability that X is greater than A equals 0.025. Okay. So notice what you have to do. You have to first convert the event X greater than A to standard normal. That you can do. X minus 10 by 5 is greater than A minus 10 by 5. So probability that X is greater than A becomes probability that Z is greater than A minus 10 by 5. What is this guy? This is 1 minus Fz of A minus 10 by 5. And that needs to be equal to 0.025. Okay. And notice how I sort of solve it using this inverse representation. Okay. So from here you get this from this equation, 1 minus Fc of A minus 10 by 5 equals 0.025. You get this equation, right? Fc of A minus 10 by 5 equals 0.975, right? So now this you have to invert, right? So A minus 10 by 5 is Fc inverse of 0.975. So A becomes 5 times this plus 10. Okay. So this is what I've done here, but this is a different problem from what I asked you, unfortunately. I think, let me see if I can quickly rectify that. So if you have to do probability of X less than A equals 0.05, this is the same as probability that X minus 10 by 5 is less than A minus 10 by 5, which is Fz of A minus 10 by 5, and that's equal to 0.05. So now you can directly invert. So this is A minus 10 by 5 equals Fc inverse of 0.05. Now this Fc inverse, like I said, is that PPF function. You can use it and find from the Z table what the value will be. And this will be A equals 10 plus 5 Fc inverse of 0.05. Okay, apologize for this bug giving you. Anyway, you get two problems for the price of one. Okay. So hopefully you got how to do this. It's not much more complicated than your previous calculations, except that you have to use this Fz inverse, and maybe that's a little bit misleading to people. So notice how I went from Fz of something being equal to 0.975 to that something being equal to the inverse function of that. So this is that inverse function. Okay. So you have to be comfortable doing these kind of things because this will happen quite often and it's quite important. Okay, I hope this is clear. Let's move on to the next question. Anyway, you've seen the solution to the next question that's here, but anyway, I think it's worth attempting. The next question is very closely related to the first one. Again, okay, so I think now I know what happened. The B part is the first question that I solved. So let me skip this one. I'll go to the third one. Okay, now I know what happened. There are actually 3 parts and I've copied only 2 parts. That's what has happened. Okay. So now this is very similar to the previous one, except that I have tried to confuse you a little bit by changing one of those events. Let me see if you see through my trickery and quickly get to the answer. Yeah. So there is a table to look up FC inverse, and like I said, most computational packages like SciPy or anywhere, you will have a function which will do FC inverse. So you can assume FC inverse is known to you. FC and FC inverse are known. Okay, they are known functions. Very easy to compute. Like I said, on in SciPy you can check out this type of function. You can check this out. This is PPF. Will is usually the inverse of the CDF. Okay, so this is a little bit twisted. It's not too hard, but you may have to find out such things. It's very useful in practice quite often when you get a distribution. You have to find out what is the maximum x can deviate about 10 with 99% probability. So if you want to be within 99% probability, what range about the mean am I looking at, right? So and this is a textbook case of that. Okay. So he thought it was PDF, is it? Okay. Sorry, I think Shekhar Arun, you mistook what I'm saying. It's not PDF, it's PPF. It's not a PDF document. It's a function in SciPy. Okay, which is a Python package for probability and all that, right? If you see the notebook that I use once in a while, I show you some demos, right? And that notebook, I will use SciPy as one of the modules. In that, there is a function called .norm.ppf, which will compute the inverse CDF for you. Most other packages will have it. If you take any computation package, it will have the inverse CDF for the standard normal. It's a very standard function, like log or exp or sine or cos. It's a standard function in some sense. Maybe I should show you. Let me just see if I can pull up something from my. Okay, people are going a little slow. Okay, is that thing called? Okay. So this is something that I do quite often when I have to compute it, since sometimes I use Python on the terminal itself, but since this is notebook, it's probably easy for you to see. So you can come down here and then do a quick calculation. So if you do norm.ppf, so this will tell you what the value of the inverse of the CDF. So if you do this gives you minus 1.645. So that's inverse CDF of 0.05, right? So this is the sort of calculation you should do. You should keep it handy that whenever you want, you can go back to that. Okay. Okay, so going is a little slow here. So let me just quickly go to that. The answer is a bit complicated. It needs a little bit of manipulation. I think, let me see. 10 plus g 0.5. 5 times f inverse of 0.99. Is it 0.99 or something mildly different from 0.99? Think about that. 5 times 1.99 by 2. Yeah, that's correct. So this answer is exactly correct. 5 times f inverse of 0.99. Is it 0.9975? I think it's just 0.995, right? Okay. 5 times fc inverse of 0.005 is not quite true. See, how do you evaluate the correctness of this answer, right? So what is going to be fc inverse of 0.005? It's going to be some negative value, right? Think about it, 0.005 probability. What area will you get? You will get a negative value. So are you going to get a negative value here for mod x minus 10 less than a? No, right? So these are ways in which you should quickly check whether your answer is correct or wrong. This answer is correct. 5 times fc inverse of 1.99 by 2. There's one minus somewhere, something has gone wrong here in these answers. Okay, so some people have got to the correct answer. Not too bad. So let me just show you the solution once again and walk you through that. So these kind of calculations are very, very important. So it's okay to spend a little bit more time on this. So this is what the question is, right? So mod x minus 10 less than a, I'm going to convert it into an event involving z, but notice there is this absolute value. So what do you do when you have absolute value? There are multiple ways to deal with it. The easiest way is to simply convert this into an event involving absolute value of z. Okay, absolute value of z is also equally good. It's a very easy random variable to deal with. So you take absolute value of x minus 10 divided by 5 is less than a by 5, right? That's all I'm doing. See, this already x minus 10 is there. So mod x minus 10 by 5 is less than a by 5. So now this is absolute value of z. Do you see that? See, this absolute value of x minus 10 by 5, z is inside. So you get absolute value of z. Okay, that's the trick here. Okay, this is the first and important trick. So probability that mod x minus 10 is less than a is probability that absolute value of z is less than a by 5. Okay, all right. What is absolute value of z less than 5a by 5? Z is between minus a by 5 and plus a by 5. And that is just fz of a by 5 minus fz of minus a by 5. Okay. We are not yet fully done here. Here you have to use symmetry. Okay. So notice how I use symmetry here. It's sort of like a multi-step problem. If you do it patiently, sequentially, you'll get it. So fc of minus a by 5, I'm going to write as 1 minus fc of a by 5, right? You see that? So this is a little bit tricky. Think about why this is true, okay? fc of minus a by 5 is 1 minus fc of a by 5, okay? So it's the same sort of property that we had before, right? So you notice this guy, right? This is the thing. So you have minus a by 5 here, I have a by 5 here. What is fc of minus a by 5? It's this guy, right? What is fc of a by 5? What is 1 minus? So this guy is this. What about this guy? This is 1 minus fc of a by 5. So you know that that's also equal to fc of minus a by 5, right? So that's the symmetry here. So notice this clean way in which this works. So once you plug that in here, you're going to get 2 times fc of a by 5 minus 1, and that equals 0.99. Okay. Now solving this gives you 1.99 by 2, which is 0.995. A is 5 times this. Okay. So notice how all these properties come together finally to give you an answer. Okay. So I hope I'm not taking too much time. I think I'm doing okay-ish. So so keep this in mind. So when you're given a problem, these kind of problems are important. And how do you solve it? You just patiently apply everything that you did so far, right? You convert to the standard normal. You may get a slightly non-trivial event involving the standard normal. So you just equate it carefully, use the symmetry property, and you can express the answer in terms of FC inverse. So now how do I numerically compute this? If I want to numerically compute this, I'll go to my rough work section here. It is 5 times inverse of 0.995. Right? So I run it. I get 12.879. That's the answer. Okay, so if I want numerically compute it, I know how to do it. It's straightforward enough. Okay, so let me come back to this this session. So if you want to numerically compute it, I need to just pick up the Python tool and then put it in, and I'll get the answer. Okay, hope that was clear. Okay, so this kind of practice is important from the normal distribution. Any computation like this in the normal distribution, given the probability, go back to the value. Given the value, compute the probability. Both of these using FC and FC inverse, you should be very comfortable doing, both in writing out an expression and in plugging it into the Python thing and getting the answer. Okay, so be comfortable with both. Okay, so next one, we are done with the normal distribution. Like I said, it's the most important distribution, but other distributions also equally interesting. Uh, let's look at the thanks Shaker. We'll see what can be done. So the exponential distribution has mean 1 by lambda and variance 1 by lambda squared, and the PDF looks like this. So lambda e power minus lambda x for x greater than 0. If you plot it, the plot will look something like this. And the most important thing is the CDF. CDF is 1 minus e power minus lambda x. Okay. So remember, once you know the CDF, you don't need anything else. Okay. Once you know the CDF, most of the probability calculation can be done in terms of the CDF. Okay. You don't need integration. You don't need anything to remember, etc. You don't need to remember the CDF. There'll be a table that will be given to you in the exam. So it's enough if you know how to open that attachment and then see it. There's one place where in the TCS thing where additional information will be there. You can go look it up. Okay. So you see, once you know the CDF, everything is expressed in terms of the CDF in a very simple way, and you just plug it in, you'll get the answer, right? So it's x less than x is the CDF itself. Greater than x is 1 minus CDF, and notice that 1 cancels, you get a simple expression. Between a and b, you can, if you do 1 minus 1 minus, you'll get this answer. Okay, simple enough. So answers for the exponential distribution you can express in terms of e power in this session at least. Okay, so let's move on. I have only one problem in exponential, simple problems, very quickly done. Okay, so once again, x is exponentially distributed with lambda equals 2. Okay, find probability. So remember, sometimes mean will be given instead of lambda, and don't use it blindly. Watch out for whether mean is given or lambda is given. If mean is given, what should you do to find lambda? Mean is 1 by lambda. Okay, so be very careful about it. So that's some mistake that students often make. So find probability that x is greater than 5 given x is between 2 and 8. Okay, it's a conditional probability. So you have to use the formula for conditional probability and figure out what you need to compute. And finally, you will express the answer in terms of exponentials. Exponentials you can enter, you don't need to find numerically what the value is. So you can express your answer in terms of e powers. You don't need to simplify it too much. Okay, so I see close to half the people have responded somewhere. Okay, so let's see the responses. Okay. Okay, one answer is just e power minus 4 minus e power minus 16. Okay. So lambda is 2, by the way. Huh? We know lambda is 2. This e power. Okay, e power minus 6 by 1 plus e power minus 6. Okay. Okay, there you go. Somebody corrected that answer, thankfully. Okay, this answer looks the most correct to me. E power minus 4 minus e power minus 10. Ah, no, no, no. Is that correct? Denominator is correct, but is the numerator correct? E power minus 4 minus e power minus 10. Is that correct? Can be a probability that x is greater than 5, right? Ah, there you go. Finally, I meet a correct answer. Okay. Oh. E power minus 10 minus e power minus 16 divided by e power minus 4 minus e power minus 16. That's the correct answer, I think. That looks correct to me. I'll show you the detailed solution in a little bit after we do the next one. Let me see if enough people have got it. E power Srinivesh. Wow. A lot of faith. E power 6 minus 1 by e power 12 minus 1 is also correct. Okay. e power 6 minus 1 by e power 12 minus 1 is also correct. But I see a lot of numerical errors and mistakes. Okay, this is correct. E power 16 minus e power 10 by e power 16 minus e power 4 is correct. I see a lot of numerical. Okay, somebody has just not bothered to do the 1 minus e powers 0.00247 numerical evaluation. Okay, good. So the correct answer is this guy here. This is probably the simplest way in which you can express it. E power 10, e power minus 10 minus e power minus 16 divided by e power minus 4 minus e power minus 16. I'll come back and show you the exact working out. It's not too difficult, but we'll see the exponential distribution play a role and you have to be very careful. Okay, so let's move on to the next one. After we do this one, I'll show you the solution to both. Okay, x is exponentially distributed against same lambda, but the event is slightly different. Mod x minus half is greater than 1 by 4. Okay, the going is a little slow. All these 1 minus things and 1 minus things, minus 1 minus things and 1 minus 1 minus things. I don't think head is spinning a little bit, right? It tends to happen. You need practice to sort of sense in which direction it should go. Oh, okay. Wait. Summit Send. I'm talking about the exponential distribution. It's a continuous distribution, right? It's not discrete. It's continuous. You have to use the CDF and all that. Okay. It's not the geometric distribution or anything like that. Okay. So it's a continuous distribution. You have to use the CDF that I gave you and do formulae with that. Okay, so I think enough people have got to the answer. Let me see if they've expressed it. It's okay. So e power minus half minus e power minus 3 by 2. Is that correct? Fx of 3 by 4 minus fx of 1 by 4. Okay. E power half e power 7 minus e power minus 9. Okay, finally I meet an answer which is similar to what I have. 1 minus e power minus half plus e power minus 3 by 2. So this is sort of the answer that I have. Okay. Remember the CDF is e power 1 minus e power minus lambda x. Okay. You should keep that in mind. Okay. So yeah, this is, so again, the mistake here is like, 1 by 4, you have not multiplied by 2, okay? It's 1 minus e power minus lambda x, lambda is 2, okay? Don't forget the lambda being 2. I think that's the small mistake here. And you have to be careful with, that's why you're getting minus 0.25. You shouldn't get minus 0.25, you should get minus half, because it's 2 times that, okay? And then same thing with 3 by 4, there is 2 times that. So it goes to 3 by 2. Okay, so this 1 minus e power minus half plus e power minus 3 by 2 is correct. I see a lot of people have made, yeah, so this one's correct. A lot of people have made numerical, manipulation mistakes, and I can see that, oh man, minus 49, this really cannot be true. This is correct, 1 plus e power minus 3 by 2 minus e power minus half. That's correct. I see if more people get converging to the correct answer. You have to calmly do the correct evaluation. So let me show you the solution here for both questions, and you can go over them. You'll get an idea of how I've gone about it. Okay. So the first problem asked you for this probability, right? Probability that x is greater than 5 given x is between 2 and 8. Okay. Now you have to first use the formula for conditional probability. I see a lot of people have forgotten about that formula and directly jumped into some solution. What is the formula? It's probability of A intersect B divided by probability of B. A is x greater than 5 and you intersect it with x between 2 and 8. What is the intersection of these two? It's x between 5 and 8. Okay. So the numerator is probability that x is between 5 and 8. Denominator is probability that x is between 2 and 8. Okay. What's the probability that x is between 5 and 8? It is the CDF evaluated at 8 minus the CDF evaluated at 5. Okay, so that's always true for any continuous distribution. Just keep this in mind. Okay, probability of x between a and b is CDF evaluated at b minus CDF evaluated at a. Okay, as long as you use the 1 minus e power minus lambda x as the CDF, okay, you will get to the correct answer. Okay, so this formula I just gave you in the previous slide. I guess people didn't write it down. Okay, so that's okay. It's all right. If you missed it because of the formula, it's okay. Okay. Okay, so in the formula, I had cancelled this one and I gave you the simplified version. Okay, go back and look at it. It will be e power minus 2 into minus 5 minus e power minus 2 into 8. Okay, so that is like the inverse CDF. I mean the complement of the CDF. Right? Probability that x is greater than. So then you'll go the other way. Okay, but this is also okay. This remember any one way, then you'll be okay. So you get e power minus 10 minus e power minus 16 in the numerator and e power minus 4 minus e power minus 16 in the denominator. Okay, so that's how it works. Okay, so check this, make sure you get these expressions correct. Sometimes you can go wrong in these expressions. Okay. Okay, all right. So now let's see this other event, mod x minus half greater than 1 by 4. Again, it's just converting that event into the proper interval. Okay, you have to do carefully. Mod x minus half greater than 1 by 4 is two possibilities. Okay, x minus half could be greater than 1 by 4 or x minus half could be less than minus 1 by 4. Okay, so this is a conversion from mod to no mod. Okay, if you say absolute value of x is less than something, x can be less than that and x needs to be greater than minus 1. If you say absolute value is greater than something, x could be greater than that value or x could be less than the negative of that value. Okay, so keep this in mind. And now it's just a simplification. X minus half greater than 1 by 4 is the same as x greater than 3 by 4. X minus half less than minus 1 by 4 is x less than 1 by 4. So now you have to just find probability that x is greater than 3 by 4, probability that x is less than 1 by 4. Again, use the correct formula for the CDF. Probability that x is less than 1 by 4 is 1 minus e power minus lambda x. So you get this guy. X greater than 3 by 4 is 1 minus the CDF of this guy. And that will give you this. So then you add it up. Okay, why do you add it up? Again, disjoint events, right? These two are disjoint events, no intersection. So you can just add and there's no need to subtract. Okay, good. I think we are doing reasonable pace. We need to speed up a little bit more. So let's go on. So I think that's all I had for exponential distribution. Next we move on to functions of distributions, functions of a random variable. This is also a slightly complicated topic. A lot of people are asking why and all these complicated formulae, etc. Let me just quickly tell you why. I mean, quite often what will happen is what is random is something, and your observed value will be that value plus some noise, and then if it goes through some function to give you some other value, you will see naturally a function of a random variable. So these things will happen again and again and again, and you should be aware of a few things, important things. What are the important things? Function of a random variable is also a random variable. It's random, but the distribution will change. The distribution will change in some manner. And it can be a little bit confusing and complicated sometimes. Okay, so some simple functions, the distribution will suddenly start looking very different. And you should be aware of that. And the main trick, the main trick is to look at this inequality f of x less than a. Okay, you have a function f, and then you look at this inequality f of x less than a, and you have to convert it, right, to all possible x such that f of x less than a. You have to sort of invert it. Okay, if I tell you f of x is less than a, where will x lie? Okay, so probability that f of x is less than a is the same as probability x belongs to that set. What all x will give you f of x less than a? So all you have to do is find probability that x belongs to this set S, and you are done. Okay. So from here you can compute the CDF. Why? Because CDF is just probability that f of x is less than x, right? Once you find the CDF, PDF is the derivative. Okay, so we can come to PDF and all later, but just generally this idea that probability of a function of x is satisfying some condition, it's not too scary. You just have to convert it into this set of all x that satisfy this. This can involve some mild tricks, but mostly it will be easy, particularly if the function is monotonic. It will be very easy. So it will just 2 or 3 step process. Okay. So let me start with finding probabilities for functions of a random variable, and I'll begin with a very simple function. Okay. There's a question from Bharat Kumar saying, why can't we convert exponential to normal? Okay, so do you mean by saying you'll make a normal approximation to the exponential distribution? Okay, so that's not really needed. So, at least in this question, supposing in a situation the distribution is exponential and the lambda, you will get much more accurate answers by using the exact distribution. You do the normal approximation only when you don't know what the distribution is. Okay, keep that in mind. Or the distribution is very complicated to calculate. Okay, so once again, there is a function f of x here, and there's some inequality given. From here, you have to sort of invert it, right? Find the x condition on x which will satisfy this. So it's a very simple linear type inequality. So you can do that manipulation quite straightforward. 3x plus 7 greater than 19 will correspond to x satisfying some condition. Okay, what is that condition? And once you do that, finding the probability for that x is very easy. Remember, it's uniformly distributed from 0 to 5. So the height of the uniform PDF will be 1 by 5. Okay, keep that in mind. Values are between 0 and 5. A lot of people simply take 1 for the height of the uniform PDF. It depends on the width. Okay, 0 to 5, the height will be 1 by 5. Okay, let me wait for a few more responses. Okay, so I think it's time to check the answers. Oh, no. X is not 0, 1, 2, 3, 5. Okay. Square bracket 0, 5. I'm thinking of the continuous uniform distribution in 0 to 5. It's not the discrete distribution. Okay. It's the continuous uniform distribution in 0 to 5. It has a PDF. The PDF is 1 by 5 between 0 and 5. Okay, keep that in mind. It's not discrete. Okay, 1 by 5, 1 by 5. A lot of people have put 0.2, 1 by 5. I think 1 by 6. It's not quite correct. 4 by 5, I think you got misled by the calculations. It's greater than 4, right? X is greater than 4. So watch out for that. 1 by 5. Yeah, 1 by 5. 1 by 5 of the full area. The full area is 1. So 1 by 5 is just 1 by 5. Ah, so he says discrete also gives the same answer. Okay, interesting. What can I say? Can get really lucky that way. Yeah, if you write with this kind of brackets or square brackets, it is uh, continuous. And if you put curve brackets and 0, comma 1, comma dot 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 comma 5, then it is discrete, right? Something like that. Or usually it's mentioned, we are talking about continuous random variables, so I didn't mention it very specifically. Otherwise, it will be mentioned discrete or continuous. Okay, so let's move on to the next function, slightly more twisted, but again a very simple. Remember the CDF if you want for the exponential distribution, we just used it. You can use that again here. Remember the trick, the first step is go from x cube greater than 27 to something involving just x, right? How do you do that is the question. Okay, so this I'm hoping is a relatively easier problem. I see many people have come close to the answer. Let's turn it up. Okay, there you go. E power minus 6, there you go. Ah, see, notice again, x greater than 3 is 1 minus the CDF. CDF is actually 1 minus. So that 1 and 1 will cancel. So you're making a mistake here in the CDF. Be careful with the CDF. So e power minus 6 is the correct answer. E power 6, it can't be e power 6. Again, remember, e power 6 is something bigger than 1. It's e power minus 6. Probability has to be less than 1. Okay, so many people have got e power minus 6. That's great. Wonderful. The next one is normal. Again, x is normal distributed, mean 5, variance 1. You have to find probability that x squared is less than 3. Again, you can express your answer in terms of FC. You don't need to simplify beyond FC. Leave your answer in terms of FC. Okay. Watch out, x takes, normal distribution, x takes values which are both positive and negative. And if x square is less than 3, be careful about how you will convert to x. Watch out for negative values of x. Okay, I'll wait for a few more minutes. It's asking some other question, which will take up some other time, Aniket. Let's see. Let's go through some of these questions first. We'll come back to this. Yeah, yes, Samit. I think many problems are solved using integration also. I agree. But can also do it differently. All right. So there you go. FC of root 3 minus 5. Okay. Is that correct? Okay, so this one's correct. Is put instead of z is put fc and then a is square root of 3. So fc of root 3 minus 5 minus fc of minus root 3 minus 5 is correct. Okay. Can't just be this, right? See, notice that's why I said x can be positive or negative. Okay. See, supposing you say x squared less than 3 is just x less than root 3, right? See, x less than root 3 minus 10 also satisfies x less than root 3. Do you see that? So minus 10 satisfies x less than root 3. So what is minus 10 squared? 100. 100 is not less than 3. Okay, so that's why I gave you that warning about negative numbers. Be careful when you convert inequalities like this, because if x can go negative, if it becomes too large and negative also, you get into trouble. Okay, so you have to be paying very good attention there. It's not, yes, I think many people have got it right. FC of minus square root 3. That's correct. This is the correct answer. So I guess 3.26 is root 3 minus 5, I guess, right? So it's correct. 5 plus root 3 is not quite right. Okay, you can't hear me. Is that right? Can other people confirm? Can you hear me? Did I lose the connection? Okay, people are saying they can hear, so I think you have to check the connection at your end. Okay, so these problems have a simple enough solution. So let me just show you how the solution looks like from my side. It's usually very simple. The trick is first is to change the event to an event in terms of x. The first question is quite easy. It just directly converts to x greater than 4. Then after that, it's just a probability here. It's just 1 by 5. The second question also works out in a very, very similar way. It's x is greater than 3, and that's just a straightforward evaluation. Here, there is this little bit of trick was to paying attention to that x can be between minus root 3 and root 3 only. If x squared is less than 3, then we can do. Okay. All right. So how will you use symmetry here? So there is a question about symmetry. How will you simplify this with symmetry? Be careful, watch out for how this term has come out, right? See, root 3 minus 5, negative of root 3 minus 5 is not minus root 3 minus 5. Okay, so pay attention to that. It's not possible to use symmetry in this case. Okay, all right, so let's move on to the next question. The next question is a bit of a slightly different question, I think, so maybe we'll skip it and come back if we have time. Okay, so I'll skip this. I'll come back if we have time. So we're going to go look at CDF. Okay, the same type of functions, except now instead of asking you, giving you one value, says 3x plus 7 less than greater than 19 or one such value, I'm going to ask for the CDF. So now when I ask you for the CDF, you have to most people forget. Okay, we lost the audio. Right, I guess it's not very surprising. Once in a while, a network goes through this kind of an issue. Am I back? Okay, all right. Okay, so let me go through. Basically, what I wanted to say is there are two steps in finding CDF of a function of a random variable. The first step is to find the range of the values of that function. Okay, see, x is a random variable taking values between 0 and 5. In the first step, you have to find the range of possible values of 3x plus 7, because 3x plus 7 will take different values from 0 to 5. Okay, what are the range of values that 3x plus 7 takes? Usual trick is to substitute the lower end, higher end, and you will get the same thing. Okay, so first find the range. Okay, and then pick a value inside that range and try to find the CDF value, probability that 3x plus 7 is less than that. Okay, so that's the trick. Once you do that, you will get the CDF. Okay. Yeah, so Aniket is asking about broadband service here. So we've been facing some strange issue with our network. Something is mildly wrong, and people have been trying to fix it for a long time now, and it's not really getting properly fixed. So something's going on. So hopefully in a week or so it should get fixed. We'll see. Okay, so I'll wait a little while. It's okay, so it's going much more slowly now compared to before. Maybe I should show the solution a little bit. Problem is, I think I've written multiple solutions in the same thing, but it doesn't matter. I think people are quite confused. So let me just show the solution uh, real quick. Maybe I should wait. Maybe I should show the solutions. Let me just show you the solution on how CDF type problems work. Okay. Okay, so here you go. So just look at the solution, okay, very carefully. First step, like I said, is find the range, okay. If x is in 0 to 5, 3x plus 7 will belong to 7 to 22. It will take values from 7 to 22. Okay, that's the first step to do. Okay, find the range first. Okay, so this random variable, remember 3x plus 7 is another random variable. This random variable 3x plus 7 will take values from 7 to 22. Okay, how did I get that? I put x equals 0, I get 7, x equal to 5, I get 22. So that's 7 comma 22. Now, if x is less than 7, CDF is going to be 0, right? Why? CDF of 3x plus 7, if x is less than 7, CDF will be 0. Probability that x is less than 7 is going to be 0 because, I mean, not x, I mean, probability that 3x plus 7 is less than 7 is going to be 0. Okay. And if it's greater than 22, probability that 3x plus 7 is less than 22 or something is 1. Okay. So CDF goes from 0 to 1 as 3x plus 7 goes from 7 to 22. This is something to sort of slightly keep in mind. But the most important thing is when x is in the range. Okay, so notice this 7, x is between 7 and 22. CDF is probability that 3x plus 7 is less than or equal to small x. Okay. Now, after this, it's exactly like what you did before, except that in the small x, you have to keep carrying on. It will not be like some value. So you have to just carry on this. Okay. So you have to convert this equation into some range involving capital X. Okay. So 3x plus 7 less than or equal to x is x less than or equal to capital X less than or equal to small x minus 7 divided by 3. Okay. So some people like to use something else other than x here. You can use small y if you like. Okay, but anyway, it's the same thing. Okay. So now all I need to do is find out the probability that capital X is less than or equal to x minus 7 by 3. Now I go to my simple PDF, which is uniform, and then I look at x minus 7 by 3. What's the probability that x is less than x minus 7 by 3? It's just 1 by 5 times x minus 7 by 3. So it's x minus 7 by 15. Okay, that's the CDF. X minus 7 by 15 is the answer. Okay, try and see the steps very closely. It's not the easiest, but it's not so twisted. Okay, so find the range of values and simply pick a value of x in that range, and then invert this general equation: 3x plus 7 less than or equal to small x is less than or equal to x minus 7 by 3, and then you do it. Okay, you can find the range in multiple ways. I'm just using just a straightforward calculation to get 7 comma 22. Okay, the PDF and all you get by derivative. Okay, all right. So this is still the trick remains exactly similar to before. There's nothing very different, except that you have to deal with this small x instead of uh, some number. Okay, so let me go to the next problem, which is very similar to this problem, except that you now have an exponential distribution with lambda equals 2. I want you to find the CDF of x power 3. Okay, so previously we found probability that x power 3 was less than 27, right? Less than 27 or greater than 27, maybe greater than 27, doesn't matter. So now you essentially have to find probability that x cubed, capital X cubed, is going to be less than or equal to some small x. Okay, and you will get one expression in terms of some exponential, etc., but you can just leave it like that. Okay. Oh, so Govind has asked the question, are we assuming uniform for f of x? We never assumed uniform for f of x, okay? So go back to the previous solution. I think let me be very clear. So we're not assuming uniform for f of x, okay? We are assuming we are not we are given uniform for x, okay? So notice here, until I come to an equation involving x, I'm not assuming uniform. Once I come to this, I mean uniform is given to me. X is uniform from 0 to 5. So I can assume this. Okay, keep that in mind. There's no assumption as far as the given question is concerned. So likewise here, I don't know the distribution of x cube, but I know the distribution of x. So you convert the event involving x cube into an event involving x, and then you use the known distribution. The CDF of x I know, right? So you use that. Let me give you a few more minutes and then I'll show you the solution. We see the answers as they are coming. Okay, 1 minus e power minus, okay, we're getting there. Good, good. Quite a few people have got it right. Very nice. So let me show you the solution in the interest of time. Let's go through and see the solution. The solution looks very similar to what we had before. It's simple in some sense. Okay, so x is exponential, CDF of x cubed. X takes values from 0 to infinity, so x cube also takes values from 0 to infinity. You can put a close open bracket here. So if you take an x value between 0 and infinity, the CDF will be probability that x cube is less than or equal to x, which is the same as probability that x is less than or equal to x power 1 by 3. Okay, and that is 1 minus e power minus 2 x power 1 by 3. So that's the CDF. Okay, the PDF involves a derivative. We can ignore that. Let's move to the next question. The next question is something very similar, but we're now using normal. Okay, so I've got normally distributed with mean 5 and variance 1. Find the CDF of x squared. The answer will be in terms of FZ, okay? Yeah, I don't think you can write the CDF without using FZ. You can leave the answer in terms of FZ. So I want the CDF of x squared. The answer will be in terms of FC, and you can leave it in terms of FC. Remember, even in the previous case, when you did probability that x squared is less than 3, the answer was in terms of FC, right? So now we are doing capital X squared less than or equal to small x, right? So Poisson distribution, the discrete analog of Gaussian distribution, I don't think so. I wouldn't say that. In some, so it turns out like the binomial distribution has a Poisson approximation. It also has a normal approximation. In that sense, might be the same, but it's not so. I don't know if Poisson, for instance, is not two-sided in general, right? It's only one-sided. The range of the transform function is in the given function range, then what to do? What do you mean by it's in the given function range? I didn't quite get it. I didn't get this question, Rishabh Pandey. You have to sort of give me an example, maybe. Range of the transformed function. I mean, the function f is in the given function range. What is the meaning of that? Okay, so there are about 12 answers. Let me just see how they got it. Yeah, so I think the first answer is correct. FC, oh, there's no 1 by root 2 pi and all. See, this capital FC is the CDF of the standard normal. It's not 1 by root 2 pi. You have to do some integration. It's not possible to write it. The first answer is correct. FC of square root of x minus 5 minus FC of minus square root of x minus 5. A lot of people have got that right. This is not correct. So this one's correct. So some people have got it right. So let me just show you what my solution is real quick. Okay, x is normal, mean 5, variance 1. What is the CDF of x squared? X is between minus infinity and infinity, so x squared will take values from 0 to infinity. You take a small x and the value 0 to infinity. CDF is probability that capital X squared is less than small x. And this is the crucial step, right? If capital X squared is less than small x, x is between minus root x and plus root x. Okay, so this is the crucial step. I think some people have some discomfort with it. Once you get to this, everything else is straightforward. Okay, x minus 5 by 1 is root x minus 5, root x minus 5. Then you do the fz of root x minus 5 minus fz of minus root 5 minus 5. Okay. All right, so that's the CDF under a function transformation. Once you find the CDF, you can find the PDF also. It's just a question of differentiation, and you will get it. Okay, so that's question 7. Let's move on to 2 random variables. Now we've come towards the end of the session, about half an hour left. The last half an hour we will spend on this, but there is a question from Rishabh Pandey. I'll take it up when people are working on this. Let me first describe the question to you. There are 2 random variables now, jointly uniform and continuous. Okay, so continuous distribution, not discrete. I've put some region here with curve braces and all. Don't interpret that as discrete. Continuous distributions, jointly uniform. And the region is 2-dimensional, okay, between 0 and 10. I want you to do a rough sketch. You can't show me the sketch. You do it on your piece of paper that you have. What is the value of the joint PDF? Joint PDF, this fxy of x comma y is the joint PDF inside this region of support. The region of support is this guy, 0 to 10. What is the value of the joint PDF? It's a very simple, straightforward question. So let me just take up Rishabh Pandey's question. Oh, so this is some minus 3 comma 1. Okay, so Rishabh, I think I worked out an example like this in my lectures. See, these kind of things are not too crucial for us. Okay, so don't worry so much about transformations and functions. I think the crucial thing is to think of simple cases, and let's not worry too much about these kind of slightly more complicated scenarios. I think I did 2 different scenarios, 2 or 3 scenarios in the class. So a little bit more complicated, and it's not so crucial for us. Okay. We will just focus on simpler scenarios where you don't have situations like this. I mean, here you have to sort of pay a little bit more attention if you want to get the CDF correctly. So if you do, see, if you do x is between -3 and 1, x square will be between 0 and 9, right? So 0 and 9, and so when you take x squared less than small x, if small x is between 0 and 1, you will have different type of region. If it is between 1 and 9, you will have different type of region. Okay, you have to just write those regions out carefully and write the CDF carefully. So it'll come out in multiple ways like that. Okay, so that part is. Hello, can you hear me now? Does this seem okay?
Yes, sir. Yes, sir.
Okay. I still have not become presenter or something. Okay, I can share my screen now. Okay, let's continue. Hopefully you can see the screen. Okay, so there were some questions going on which I was trying to answer at that time. I've got what it is now. Okay, so those questions disappeared. That was -3, 1, etc. Anyway, so let's come back to this. Many people have got the right answer. They've got 1/100 as the correct answer. I think some people have got 1 and various other. X is 0 to infinity. No, X is not 0 to infinity. X is from 0 to 10. And Y is 0 to 10. It's jointly uniform in that region. So you have to do it slightly differently. So let me maybe show you how this joint distribution will look. Okay. Okay, so this is the sketch. Okay. So you have the region, you can draw it. You should always draw an XY plot. Any two variable problem, I do this. I always draw the XY plot. It gives me some clarity. I look at the range of X, it goes from 0 to 10. Range of Y, it goes from 0 to 10. I mark out the whole area. And this area is equal to 100. Okay. Question looked like okay, so X is 0 comma 0 less than okay. Sorry. Yeah, it's I'm sorry if I write like this. I think I was just being lazy. I think it's basically 0 less than X less than 10 and 0 less than Y less than 10. It's not X greater than 0 and Y less than 10. Sorry. Okay, it's X comma Y together. Some shorthand notation. I was hoping it's clear. Okay, again, there is a mistake here. It's not 0 less than xy less than 100. It's 10 only. Let's see if I can correct it. This is correct. It's 10. Okay. So that's the way to think of it. So this is the problem. So supposing you have two random variables which are uniformly likely to lie between 0 and 10, their joint PDF has value 1/100, 1 by the area, or total area, right? So this is the thing to remember. I hope it's clean enough to people. Okay. So once you have a joint PDF like this, there is these questions of what you can ask about X alone, right? What is the range of values taken by X? What is the PDF of X? X alone, the marginal PDF of X, and evaluated at 5 is what I've asked. Okay. So that picture is very, very important. Have that picture in your mind. It's just x taking values from 0 to 10, y taking values from 0 to 10. Then within that square, X and Y are uniform jointly. So they have 1/100 as the PDF. And if you want to find the marginal of X, you're going to integrate over Y the PDF, right? So in some sense, it's just a area sort of computation. Okay, so there are about 10 answers. Let me just quickly go see it. There's 1/10, 0.50 to 100, 1/20, 0.1. Okay, yeah. Okay. So enough people are slowly converging to the answer. That's good. 1/10 is correct. I'll show you the solution in a little while. Let me ask you, maybe I should show you the solution, describe this, and then go forward. Yeah, let's do that. So you can see here, that x takes values between 0 and 10. Okay, 0 and 10 is the value that x takes. X alone takes value 0 to 10, y alone takes value 0 to 10. Okay, and the PDF of x. So the way to visualize this is go to one particular value of x and then look at all possible values of y. Okay, they're all above it. So you've got to integrate from 0 to 10 1 by 100, and then that will come out as 1 by 100 times just 1 integral is y from 0 to 10 is 1 by 100, 10 minus 0, 1 by 10. So this kind of constant thing is easy enough, right? So you just focus on that particular value of x. You have a constant value of 1 by 100. The length is 10. So it's just 10 into 1 by 100. So you get 1 by 10. Okay? You can compute the expected value of x if you like. It will come out to be 5 because x is uniform. Okay, so fx of x is 1 by 10. For all values of x between 0 and 10, fx of x is 1 by 10. So x ends up being uniform from 0 to 10. Okay, so uniform in a square, you will get uniform from 0 to 10. Okay, that's easy enough question. The next question is slightly more tricky. Same distribution, but asks for a conditional distribution. Given x equals 5, what is the range of values taken by y? What is fy given x equals 5 of 5? It's something very similar. This is a minor twist with the conditional probability. Okay, so once again, remember this is conditional, right? What is fy given x equals 5 of 5? You have to find the conditional distribution, and once you find this conditional distribution, it will work out, and you have to use the formula for how this conditional kind of distribution is derived. Okay, so there are about 9 answers. So let me just see what the answers are. Again, 1 by 10. I think, yeah, 1 by 10 is correct. Some people have got 1 by 10. That's good. That's good to see. Let me quickly show you the solution that I have here. You can see how the argument goes. It's a bit delicate, but you have to follow it very carefully. So first of all, given x is equal to 5, the entire range is possible here. Y takes values from 0 to 10. That's good. And you also know that fx of 5, PDF evaluated at 5 for x alone is 1 by 10. Okay, so these two are good to know. The reason why you need that is fy given x equals 5 of y for any y, okay, for any y between 0 and 10 will be fxy, the joint PDF evaluated at 5 comma y divided by the marginal PDF evaluated at 5. Okay, so this is the formula. It's almost like A intersect B divided by B, right? The probability of A given B, you have to sort of remember it like that. At least I remember it like that. The PDFs and the probabilities sort of follow the same equation. Okay, so PDF, conditional PDF is joint PDF divided by marginal PDF. Okay, so y given x equals 5, y equals y is fxy of 5 comma y divided by fx of y. What is the joint PDF value? It's always 1 by 100 divided by the marginal PDF is 1 by 10. So you get 1 by 10. Okay, it's easy enough, right? Something to, I mean, it's in this case, it's quite simple, and in some cases, it can be a little bit more complicated, but hopefully, I mean, Like I said, this course doesn't emphasize too much on these things, but basic idea of what it is good to have in some sense. Okay, so the next question is about are x and y independent? Let me not let you try and answer this question. I'm not going to give you too much time. I'll give you just 1 or 2 minutes. What do you think? I mean, this distribution, jointly uniform 0 to 10, are x and y independent? So given x, do you gain any particular new information about y? It doesn't look all that much like that. Okay, let me see what people are saying. Yes, 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 1 by 10 into 1 by 10. In fact, some people know the formula. Oh, so one person said no, 1 or 2 people said no. Okay. So this ends up being the case of example of an independent pair of random variables, and you can check that by this, right? So if you look at the marginal of x, you get 1 by 10. If you look at the marginal of y, you get 1 by 10 again. The product of the two marginal distributions, 1 by 10 into 1 by 10, you will get 1 by 100, which is the joint, right? 1 by 100 is the joint one. So you see that the marginal multiply and give you the joint. So x and y become independent. So this is, so another way to think of it is x takes value 0 to 10, right? And whatever may be the value of x, y seems to be having the same distribution. Whether x is 0.1 or x is 1 or x is 5 or x is 10 or x is 7, whatever may be the value of x, y has the same distribution, right? You look at that cut, that particular slice, it's the same, it's flat and it's the same. So nothing changes. Y takes the same range of values, same distribution. So it ends up being independent. Okay. So there's some expected value calculation. I'll skip that. I'm not going to present that or ask you to do that. We'll move on to another very interesting case where the problem is slightly different. Okay. So this question is very interesting. So there is x and y are jointly uniform in a region like this. Look at this region. The region is x is between -2 and 0, y is between -2 and 0, and it's a union, and x is between 0 and 1, y is between 0 and 1. It's the union of two squares. There are two squares here. One is from -2 to 0, the other is from 0 to 1. Okay. Okay, so I want you to sketch the region and what is the value of the joint PDF in the region. Again, a uniform distribution, but it's not one rectangle. There are two squares which together make up the region of support. So you have to be slightly careful computing things. Sketch the region. I think always begin with a sketch. Like I said, any two-dimensional problem, first start with a diagram. It can be the simplest of diagrams, but just make sure you draw it correctly. Make sure you understand where all your pair of random variables are going to lie. It's like a scatter plot, right? So think of that. Okay, so we are not really too much in. Okay, so there you go, 1 by 5. Most people who got an answer have got 1 by 5, 5 by 4 is not quite correct. 1 by 5 is the correct answer. The area, like, yes, exactly. This is the easiest calculation. The total area is just 5. So you can get to the answer, okay? So let me just quickly show you how the answer looks in the way I've drawn it. So this is the way to draw it. You can quickly draw -2 to 0, 0 to -2. Maybe I should zoom a little bit. Okay. 0 -2 to 0, 0 to -2, 0 to 1, 0 to 1. So you have this area and this area. It's 2 into 2 plus 1 into 1. You get the right area there. So fxy of x comma y is 1 by 5 in that region of support. Okay. The next question asks for the marginal of x. So let me try and see if you can work that out. The next question is, what is the range of values taken by x alone? What is the PDF of x alone, the marginal PDF of x evaluated at -1? What is the marginal PDF evaluated at 0.5? Remember, the height is 1 by 5 in that area, only in that area. Outside of that, it's 0, right? That's the joint PDF. So keep that plot in mind. That tells you the values taken by x. For a particular value of x, you will know the value taken by y also. And then you have to integrate y out. So in this case, it's just a flat integral. So it's just the height 1 by 5 over what length? You just have to find that area. Okay, we are running a little bit out of time, so I'm going to speed up a little bit. So -2 comma 1 is correct, and then 0.4 and 0.2 is also correct. 2 by 5 and 1 by 5, some people have got it. Let me just quickly show you how my solution looks. I'm sure many of you would have got it. X belongs to -2 comma 1, that is the range of values that x takes, right? You can see that -2 to 1, that's the range of values in y. At -1, notice y goes from -2 to 0, okay? So you can integrate from -2 to 0, 1 by 5 dy. So that will be just 1 by 5, 0 minus -2, so that's 2 by 5. So if you can do that with integration, or just look at that -2, you'll see that 1 by 5 flat all the way from 0 to -2, so that's 2 by 5, okay? And then 0.5 on the other hand, y goes from 0 to 1. That's completely different value. If you integrate that out, you will get 1 by 5. Okay, so there are two different regions, two different values for the PDF. So in fact, if you have to write down the marginal PDF of x, how will that look? X will take values from -1 to -2 to 1. So maybe I should do that. So if you look at this, if you have to do the plot the marginal PDF of x, that's going to be from -2 to +1. It will be 2 by 5 when x is negative. It will be 1 by 5 when x is positive. Okay, so it will have a picture like that. Okay, so you remember that. So it's a slightly different looking PDF. In fact, it's not uniform. X is not uniform in the range -2 to 1. Okay, it has a sort of a larger probability of being negative. than being positive in some sense. So that you can see from this picture also, right? It has a picture like this. Okay, so there's some chat question going on. Yeah, sure. I'll take care of this -2 to 1. Only from -2 to 1 PDF is defined. That's correct. PDF is only from -2 to 1. It is 0 otherwise. Yeah. Okay. So that's the PDF of X. Okay. So there can be a similar question asked to last time. So the conditional PDF. So now look at this. This is the next question. Given X is -1, what is the range of values taken by Y? And what is the conditional PDF of Y given X is equal to -1, -1? Same thing with 0.5. Given X equal to -1. Oh, okay. So I think I messed this up a little bit. Okay, anyway, let me just, yeah, it's okay. Let's just leave it like that. This question is okay. Same distribution as before. Remember that plot, once again, always remember that plot. That will give you the picture. Given X is -1, what is the range of values taken by Y? What is the conditional PDF if Y given X equals -1 of -1 and if Y given X equals -1 of 0.5? We're coming towards the end of this session. We've already crossed it by 2 minutes. I just want to do this and the next question and we'll be done. Just a couple of more questions. So let's quickly finish it off. I'll wait for 1 more minute and then show you what responses people have put out. I think everybody is getting totally tired. Let me see if I'm lucky enough to get 1 more response. Okay, got a couple of more. Okay, so let me just show you. Okay. Okay, yeah, that's correct. I think it's in the middle of writing the answer. Half comma 0, yeah, 0 comma -2, 0.4, 0.4, -1 condition is half 0.5. Okay, 0.5, there seems to be some confusion here. Anyway, so let me show you the solution that I have once again for this one. Here's the, so one needs to be slightly careful here. Watch out. I think most people got the first part right. The range of values of Y when X is -1, it's between -2 and 0. Okay, that is correct. But when you find the conditional probability, conditional density, right? Fy given X equals -1 of -1, it's Fxy of -1 comma -1, the joint PDF divided by the marginal. Be very careful about it. Marginal of X evaluated at -1. The joint PDF is actually 1 by 5, but the marginal is 2 by 5. So 1 by 5 divided by 2 by 5, it will become 1 by 2. Okay, it's 0.5. How do you quickly get to 0.5? You know how I quickly get to 0.5? This is what I do. Okay, so for uniform, this is a trick you can very easily use. See, every conditional, every marginal is going to be uniform. That's the trick, right? Because it's all flat. Everywhere it's flat. Any marginal, any conditional is going to be uniform in this case, right? So given X equal to -1, Y is actually uniform between 0 and -2. Right? Think about it, because the joint PDF is uniform, is constant, divided by fx equals fx of -1. It's just uniform. So it's 1 by 5 by 2 by 5 is 1 by 2. But another quick way to get there is, given x is -1, y takes values between 0 and -2. So it's uniform from 0 and -2. Something that's uniform from 0 and -2 has to have a height of 1 by 2, right? That's enough. That's another quick way of doing it, okay? If x is, then y 1 by 5 and why not 1 by 4? Oh, no, 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 no. See, be very careful, right? The PDF is 1 by 5 everywhere. It's not 1 by 4. The PDF is always, the joint PDF is 1 by 5 everywhere. Given x is -1 is one condition on x, doesn't mean the joint PDF will suddenly change. It will always be 1 by 5. The entire region of support is 1 by 5, okay? Keep that in mind. Okay, so don't be misled by that fact. Okay, so y is uniform from 0 to -2, so the height better be 1 by 2. Okay, now look at this other question. This is a little bit tricky, bit of a trick question there. Okay, if y given x equals -1, given x equals -1, what's the conditional density evaluated at +½ Okay, so it turns out that value will be 0. Why? Because the joint PDF is 0 at -1 comma half. Go back to this picture. It says, oops, what did I do? Sorry about that. But I have to now move from one. Yeah, so this is the thing I wanted to show you. I think I was zooming a little bit. Good to zoom. Okay. So look at this picture. This picture conveys all the answers you want. Given x is -1, y cannot be 0.5, right? That should be 0. It's just direct, straightforward. You can do the formula and the substitution and all that, but the joint PDF at -1 comma half is actually 0. So it can never take the value -1 comma half. So if you look at the condition probability like this, you should just get 0. Okay, so that's the trick. That's the important part here. Okay, so we'll stop with this last question. I know I've exceeded my time a little bit. Apologies for that. The last question is, are x and y independent? Okay, with this we'll stop. There are a few more questions. I'll let you see the answer yourself when it gets posted. Okay, so okay, once again the same distribution. Are x and y independent? That's all. That's the question. Okay, so the way you get half directly is, see, every conditional distribution is uniform. That's the main trick there. If that is the case, then you condition on x equals -1, y takes values from 0 to -2, and it's uniform in 0 to -2. Any distribution that is uniform from 0 to -2 has to have a height of half, right? The uniform distribution from 0 to -2 will have a height half. That's all. That's the idea. Okay. So it will also work out to half. If you use the formula also, it will work out correctly. Are x and y independent? That's the question. Okay, so this is the last question for the day. So Rishabh was asked a question about, given an inequality with a straight line, how do you know whether it's above or below? I usually take one point on the line, and then I take a point uh, below the line and take a point above the line and evaluate the inequality and check. I just check like that's that way I'm 100% sure which side it is. You take the inequality for the line and then take a point below the line. Evaluate the inequality, see if it is satisfied. If it's satisfied, you're below. Or you take a point above the line, evaluate the inequality and see if it's satisfied or not. Usually that's my trick. Usually if the origin will be 1 point, you'll know if it's above the line or below the line, right? You can use the origin. You can use some other point if the origin is on the line. You just use 1 comma 0 or something. So you either use 0 comma 0 or 1 something comma 0, one either to the left or right, then you'll get the answer. Okay, it's about 8 answers only, 9 answers. Let's see. No, no, they're not independent. They're not independent. Yes, some people are saying it's independent. They are not independent. Okay, so let me just close with why these two cannot be independent. So if you go back once again and look at the picture, right? So let me just show you the solution here. If you look at this picture, see, if the value of x tells you something about y. If I tell you x is -1, y lies between 0 and -2. On the other hand, if I say x is 0.5, y lies between 0 and 1. Completely it has changed. If anything changes like that, then it cannot be independent. Okay, so that's something very, very easy to remember. Depending on the value of x, if the range of y changes, okay, definitely it cannot be independent. It's the end of story, right? Because once the range changes, doesn't matter what the actual distribution is different. Okay, so if the range of y is different for particular x, two different x's has two different ranges of y, immediately you know it's uh, not independent. Okay, so it's dependent. Okay, you can also calculate it. There's a calculation I've shown here in the solution. I took this point -1 comma 0.5 and showed how the joint PDF is 0, but the marginal PDF is not 2 by 5 and 1 by 5. Product of the marginals is 2 by 10, 2 by 25. It's not 0. Okay, so you can calculate and check like this. But the easiest check in my mind is just look at this region. There is one range of values of x for which the range of y is 0 to -2. The other value of x where the range is 0 to 1. The range changes for y, and that immediately means it is dependent. Okay. All right. So I think that's the end of this session. It's been a relatively long session, and I think we did quite a few topics. A lot of you have braved and bravely stayed on and looked at this. Thanks for joining in the evening. I hope this was useful to you, and I hope this topic is. So a couple of things I want to say about this topic. Okay, a few things about continuous random variables. All these great integrations and all this is not relevant to us. Okay, you can throw it into a computer. The computer will do an integration, give you an answer. It's not important. What's mostly important for us is what is the type of values, what is the type of the distribution, where is it most likely to occur, where is it least likely to occur, the CDF, and how to plug it into a formula, particularly for normal distribution, how to plug it into a formula and compute the values in different ways. That is important. In two-dimensional distributions, what is the relative spread of values? Where is it more likely? Is it independent or not? Can you assess that? What are the marginals as x shifts? What are the conditionals as x shifts, as y shifts? Those kind of things are good to know, because quite often you will have a use for these kind of things. So don't stress yourself out about complicated integrations. Okay, complicated integrations are not really the emphasis of this course. At best, you will have integral x dx, integral y dy, things like that. Very simple integrations where the standard formula will apply in this course, as far as this course is concerned. The important thing is how to compute probabilities involving continuous distributions, how to assess independence, dependence, and all that, given the two-dimensional distribution, how to get to these conditional distributions and what they mean. Okay, so these solutions and the questions will be posted on the website. Please take a look at it and have a good night. Bye-bye. Yeah, sure. Well, there are some special sessions shared for, live sessions scheduled for Math 2. We'll keep that in mind. Okay. Thank you. Bye bye. Good night.